let's consider 64 to the 2/3 power. What does that mean? The denominator tells us the kind of root we have, and I often find that it's easier to do the root first because then you end up with a number which is. For that, we're going to square. Well, the cubic root of 64 is 4, and if we square 4, we end up with 16. We could do it the other way around too, but then that would mean that we would have to be taking 64 to the 2nd power first, and then taking the cubic root of that. But 64 to the 2nd power, that's a little bit too large of a number to work with. Sure, we can do it easily with calculators, but I find it easier to do the root first. Either way is fine. Let's take another example. What about 36 to the negative 1/2 power? Well, just as we've had with negative exponents before, we can make the exponent positive, and when we want to evaluate numbers, we want to do that. Make the exponent positive, and consider this as 1 over 36 to the 1/2 power. But the 1/2 power is nothing but the root, so this is the same thing as 1 over the square root of 36, and of course that simply gives us a 1/6. So there's no problem. Now, be really careful again, as you were warned earlier when you worked with exponents, be really careful about misinterpreting negative signs. For example, if we have minus 9 to the 1/2 power or negative 9 to the 1/2 power. Be careful, this means the negative of 9 to the 1/2. And because it means the negative of 9 to the 1/2, it's the negative of the square root of 9. And of course the square root of 9 is 3, so this is just equal to a minus 3. That's very different than saying minus 9. Okay, and this isn't a real number. And so we can't separate, we can't say negative 9 to the 1/2 is the square root of negative 9 because it's not a real number. But the main thing I wanted to these two. Where here the exponent or the sign, the negative sign is in front of the number, here it's inside the quantity which is raised to the power. So be careful with that. That often is something that... All right, what if we have a quotient to a rational power? Well, that's no problem at all. We know how to work with quotients to power, so it's the same thing when we have those to rational powers. So suppose we have 36 over 25. Let's call this an example. 36 over 25 to the negative 3/2 power. In evaluating a number, I want to write the exponent positive to the positive 3/2 power. But that's the same thing as saying I'm going to be taking the square root of 36 because the denominator is a 2, the denominator of the exponent. So, and then I'm going to take that to the 3rd power. Okay, well, we know that the square root of 36 25ths is 6/5, and now we're going to be taking that to the 3rd power. But that's the same thing as saying this is 1 over 6 cubed over 5 cubed. That's the same thing as saying this is 1 over 216 over 100. Multiply, so this is the same thing as 125 over 216. Anytime that you've got a negative exponent and the quantity raised, the base of that is a quotient, remember that we can also say that this is the same thing as plus 3/2 power. We used that trick before, and that's the same thing as the square root power, which again gives us 125 over 216. So the nice thing with exponents is you can choose the way that you want to go, whatever you're comfortable with. One of the things that I would recommend for this chapter in working with rational exponents is I would recommend that you memorize the easy powers of integers. And by those I mean the following. I would memorize 1 squared equals 1, 2 squared equals 4, and so forth, all the way to 12 squared. 3 squared, 4 squared, 5 squared, 12 squared. If you know those very easily, it'll save you a little bit of time. 12 squared, of course, is 144. And I would also recommend that you memorize the cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and let's stop at 5 cubed. This will save you a lot of time. Okay? So basically, the thing to remember with this lesson is that if you have the nth root of a, you can convert that to a to the 1 over as the nth root of a is a real number. It's important to keep that in mind. And once we convert to exponents, then we can use the properties of exponents.